All right, well, here I am, live and in color. I am actually here with you excitedly in a very relaxed attire today because I am going to hang out with my family. I'm very excited about it. Um, and so I decided to just be a little more casual, a little more personable today, especially considering the nature of the discussion. I know that you've seen a lot of scientists like myself in lab coats. You've seen some scientists at the doctoral level. You've seen some scientists who are not at the doctoral level, and they're still yet skilled in their area of expertise and specialization. You've seen medical physicians in their formal attire, or at the very least in their polo button up shirts, collared shirts. And I decided that I know that because you're inundated with information, you're inundated, you're not really sure what should I do, but you do know generally, as we have become so commonly unimpressed with, and almost humorously so, are pharmaceutical recommendations. And even where this is a vaccine, and sometimes you don't necessarily consider it a pharmaceutical, which it is. And I'm sure that there may be some pharmacists that may, want to interject. But just for semantics, we can definitely consider them in the same family. Not literal scientific classification of pharmaceuticals or drugs, but we can consider them in the same grouping, categorization, nomenclature for semantic purposes only. That the vaccines are, that pharmaceutical. And so when we think about these over-the-counter pharmaceuticals and we think about the prescription, we are again unimpressed, and humorously so, about the fact that they may have this benefit, this purported, or this asserted benefit, and then the side effects. Dun 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 dun. All right. So if you are interested in getting just clarity and just just having full uh, uh, relief from this smog of information. Some of it is disinformation, some of it's valid, but if it's all together in this smog, it's very hard to ascertain truth from lies. I admit it myself. Okay, so this, you're seeing the live version of this. I hope you can join me. I'm not sure if you saw my post on this, and that I made a little earlier. And I know you see a bit of the glare, the lighting, or whatever. But the point is that I want you to see me. Yeah, absolutely, whatever, something like that. But mainly, I want you to be able to see the video that I'm going to run. I am not co-signing any of the information that is shared. I just think that of all the videos that I've watched and trying to have an additional element, some of you are familiar with the fact that I am also a teacher by formal academia, having taken the same certified or certification program as other teachers. And of course now, and that would have been in my bachelor's program. And of course now, I am only steps away, or one step away, literally, from my doctoral degree. So that would have qualified me, of course, for professorship. So nonetheless, I want you to not so much as look at me today, even though I feel like I look amazing in my casual attire. I want you to see this video because it is the most straightforward. And whereas I do not agree with some of the points, because sometimes like the Seeker videos, you've heard me and you've seen the posts that I've made. Seeker does a wonderful job of simplifying information for the masses. That's wonderful, but sometimes in that simplicity, there are errors that fail to articulate the true scientific application of the subject matter at issue. So, but I think this does a general good job of all the ones that I've watched. And so I'm gonna remember I told you I wanted to try different medium or media. And I can explain this to you, but we all learn and receive information and process information differently. So I'm going to definitely supplement and enlarge what this young man has said in his video. He is a PhD holding, he doesn't actually state that whether or not he actually teaches or is a professor, associate, adjunct, or otherwise. But he does hold his PhD. Okay, all right. And even when I looked at his intro, it doesn't really go into detail as far as what his dissertation was on. But it's not really all that relevant as it relates to this specific video because it really is just so wonderfully simplified and generalized, if you will, without completely abandoning the technical aspects of it all. So here we go. I'm going to allow even the joke at the end to run, even though I do not concur. I know that we're doing our absolute best, scientists, because we know that generally scientists are introverted. That's the stereotype, which is not true. Remember, it's a generalization and an overgeneralization at that. But there is some validity. Most of us scientists prefer to be in the lab. Even those of us who are extroverted, like myself, I still have a great preference to be in the lab or the field, and that's just the nature of the job. Okay, so but we are doing our absolute best to come to the forefront and present ourselves approachable and be lighthearted and even offer an element of humor, much like the wonderful Neil deGrasse Tyson does on Star Talk and Dr. Bill, well, not, it's Bill Nye, and there's, I can't think of her name. In neurology, she also was an actress. You all will know her name. I can't think of her name to save my life right now, okay? But we're getting there, but the joke is just not, it's just not in good taste, but it's okay. It's because it's not accurate. Okay. But nonetheless, it's fun. So here we go. And I hope that you can see and hear it well. And like I said, I am working to use other video platforms like Zoom, but I'm working out all the kinks. So keep with me because the information will be no less viable. All right? Okay. And before I begin the video, let me start by saying welcome. I am Tigress Sydney Acute McDaniel. I like to go ahead and just jump right on in because we have so much that we have to cram into an hour-long session, and I am doing my absolute best to bring you as much as I possibly can that is in this head of mine about science and this particular science and the sciences that are related to my expertise and that really matter as it relates to your everyday life and governing of this country and our well-being and our progression and evolution. And we can do it. We can evolve people. I believe in you and me because I got to help out in this process too. I can't just sit on the sidelines. That won't work. All right. So my affirmation is that what? That I further enlarge and inspire, positively contribute to our overall understanding and our growth process in humanity, and that I not further cause divide. All right, roll that beautiful beam footage.
Intrusion system and a camera system all speaking together.
This is how coronavirus invades your body, sinking its crown-like spikes into your cells, using molecular deception to pick their locks, and hijacking your body. But there is one way to prevent this, by using one of the virus's weapons on itself. Hey, smart people, Joe here. Right now, there's about 7 billion people all waiting for the same thing, a vaccine that will protect us from the virus causing COVID-19. And if you're like me, you want to know what's in it, what makes it work. Making a vaccine and getting it out to the public is a long process with a lot of steps, so we can make sure the vaccine is safe and effective. And it's pretty typical for that to take 10 years or more. But in an emergency, like this pandemic, well, we can skip any of those steps, but we can speed this up by doing some of them at the same time. But none of that can happen until you figure out the first step. What do you put in your vaccine that will make it protect people? And that's what we're going to talk about today. We're going to visit a lab and meet some scientists who study the coronavirus. We're also going to meet a really big, awesome science machine and learn how they used it to design this, the key ingredient inside the very first COVID-19 vaccines. And here's my goal with this video, to show you what exactly is in the new COVID vaccines that makes them work, and how they got made faster than any vaccine in history. My hope is that you'll be better informed when you get your shot, and you'll have a new appreciation for why science like this is so important. This is how to make a COVID-19 vaccine. It turns out that some of the most important research for making the COVID-19 vaccine is happening right down the road from me at the University of Texas, which is pretty cool because I did my PhD right here. And in here is the lab of Dr. Jason McClellan. He studies how pathogens like coronavirus cause disease.
There are 4 human coronaviruses that occur seasonally and generally cause the common cold. And then there have been 3 coronaviruses that have caused pandemics. And that's the first SARS coronavirus back in 2002, the MERS coronavirus in 2012, and now SARS-CoV-2, which emerged earlier this year. At the end of December 2019, it was on the news that there was these pneumonia clusters in China. In the scientific community, thought maybe a new flu virus or possibly a coronavirus. I was actually snowboarding with my family, and my collaborator, Barney Graham, at the Vaccine Research Center at the NIH called, and he said he's been in contact with US CDC, Chinese CDC. It looks like it's a beta coronavirus, similar to SARS, and they wanted to move rapidly, try and make a vaccine. And I said, we're definitely in.
So you're just like scrolling through your phone in this ski lodge.
Like, we gotta get to work. So while the rest of us will focus
Excuse
on what
the display of what seems to be white privilege. I think they mean well. Just keep up with me. Come on.
Serious. They were already getting to work. As soon as researchers in China decoded the virus's genome and published it online, Jason's lab could start designing a vaccine.
I texted Daniel Rath, my graduate student, and let him know to be on high alert, because as soon as we get the sequence, we're going to move as quickly as we can.
Jason was on that winter vacation and texted me that it was a coronavirus, and eventually in early January, the sequence was released online publicly. And then things started moving pretty quickly.
Let's step back for a minute. What does a vaccine do? Well, it trains your immune system to know what a germ, like a virus, looks like, so that it can recognize the germ, fight it off, and keep you safe without you getting sick. This is the virus that causes COVID-19. The outer shell is made of a few different kinds of proteins, but these proteins sticking off the side are the most important part, the spike. These spikes are what give this family of viruses their name, the coronaviruses, because they look kind of like a crown. The coronavirus uses that spike to sneak into our cells. The three-dimensional shape of that spike is super important because that exact shape is what lets the virus latch onto receptors on the outside of our cells, almost like picking a lock. And then it sneaks inside. Those shapes sticking out on the outside of the virus are also what your immune system is feeling for, to figure out if this is a foreign invader, if it should attack or not. The problem is, the first time the body sees a virus, your immune system responds so slowly that the virus has time to make gazillions of copies of itself. You can still get very, very sick. That's what's great about a vaccine. It trains your immune system what to look for, so when the real virus shows up, your body can respond super fast and destroy the virus before it has a chance to hijack your cells. So what's actually in a vaccine? Well, sometimes a vaccine has a weakened or dead virus. That's how polio and measles and mumps and some other vaccines work. But these days, a vaccine usually just contains a little piece of the virus. The newest COVID-19 vaccines, they're just the spike. But for that spike to work as a vaccine, to train your immune system to recognize the actual virus, It has to have the same three-dimensional shape as the spike on the whole complete virus. But making the spike all by itself, not attached to the rest of the virus, it turns out to be really hard because the spike is actually pretty floppy, just floating around on its own. It doesn't look much like a spike on the actual virus. And this is the key thing Jason's lab figured out how to make. For years, they'd studied SARS and MERS viruses, which are really closely related to the virus that causes COVID. So they already knew what tiny tweaks to make to convince the coronavirus spikes into the perfect shape.
So we got to work designing our stabilizing mutations into the new spike sequence. There was just two amino acids that we knew would, if we mutated them, it would stabilize the spike protein, make it a lot easier to work with in the lab.
A protein.
So
like
this
the coronavirus
is
spike,
this is not showing anything but the spike protein methodology for vaccination,
and stored in DNA.
as opposed to the adenovirus. And I'll go over
We can
that.
change the amino acids in our protein string.
It's cool. They're like building scaffolding. Into
It's only 10 minutes long, people. It will go by pretty fast.
How do you from there to making the actual spike protein?
I can show you.
Scientists are able to grow special immortal human cells outside the body, which they use as factories. They put a modified gene or something like their spike protein into those cells.
And then they'll start spitting out this protein.
So they're just pumping it out into the liquid.
Yeah, that's right.
They take that liquid, run it through special purification machines, and are able to isolate a pure sample of their spike protein. But how do they know for sure that this special spike protein looks like the real thing, 3D shape and all? Well, they take pictures of it using a big, awesome science machine. This is a cryo-electron microscope. This
And yes, if
machine
you're thinking
creates a picture of the
nanotechnology,
coronavirus
yes.
to help design the very
Yes.
first COVID-19 vaccine.
Okay.
Check out the big science machine.
Looks like a giant microwave. I mean, the room is like $1 million, and the microscope's another $1 million.
So you're saying don't touch
Yeah.
your screen, right?
So you can see like the floor is separate from the instrument, so it's on its own. Vibrations are bad. These are wall panels that contain water running behind them to keep the temperature constant in the room. And then it also has to be electromagnetically shielded too.
That is nuts. Beefy cable over here.
So that's the 200,000 volts coming from that.
Okay, yeah, so I'm with that one.
Yeah.
Oh, this is
Sciencey.
look at all that science happening there.
Right.
Did you know Ring puts your whole home at your fingertips? Keep an eye on your stuff from here.
Kind of a marvel at physics and engineering.
Can you play Doom on this thing?
Some of our computers, you'd be able to play at max settings.
So maybe this sounds like a super stupid question, but why can't you just use a regular light microscope to take a picture of a protein? Well, the wavelength of visible light is on the order of hundreds of nanometers. And that means the smallest things you can see with visible light are also
That
visible.
is what? A blood cell.
But what we want to see, the atoms in a protein molecule, they're angstroms apart, tenths of a nanometer. So we can't use visible light. We have to use a special electron microscope.
So super high energy electrons make.
And some of you know this from science. Some of you remember it in high school. Some of you know it from your advanced academia. Proteins are what? Like amino acids, building blocks of life.
You can go angstrom kind.
So to take a 3D picture of a protein with a cryo-electron microscope, first you put a drop of protein onto a special metal grid. Then you freeze it in place with liquid ethane. When we shoot a beam of electrons at it, these proteins will be in all kinds of random orientations. Each orientation leaves a particular shadow. Powerful computers look at all of those 2D images and then combine them into a final 3D shape. It's kind of like using a bunch of 2D photos to make a 3D model. When Jason and Daniel and their team looked at the spike that they made with their tiny little tweaks and mutations, their spike has the same 3D shape as the spike on the whole virus.
Pretty cool.
Now we can put that spike into people and see if it trains their immune system and protects them from the real virus. And it works. This protects people from COVID-19. The research you just saw from those scientists.
Pfizer,
is literally what's being used in the
Biotech, Johnson
very
& Johnson,
first
Novavax,
vaccines.
Moderna.
And some of those vaccines work in a really cool way. Instead of having to
The
make
Janssen
actual spike
vaccine
protein, these big
is different.
factories with huge tanks of cells like the
It
ones we
uses
saw. Some of these new vaccines,
the
genetic
mRNA
instructions for
method.
making the spike is all that's in the shot on a molecule called mRNA. Your body uses those instructions to make the spike. You are the factory. That's awesome. This is a really incredible piece of science. A year ago, no one had ever seen this virus before. And thanks to these scientists and thousands of others around the world, now we have vaccines that work. I mean, it's going to take months, maybe years, to get these vaccines and dozens of others still being worked on to the billions of people that need them. And that's a huge challenge on its own. But this is a really hopeful story. No vaccine in history has ever been invented this fast, and we were able to do it safely. We were able to do this so quickly.
This has been done in
because
about a
scientists like
6-month
Jason
period.
and his lab and others, they were ready because they were studying basic scientific questions about other coronaviruses, SARS and MERS. They spent years trying to figure out their secrets so that when this one showed up, they were already 10 steps ahead. And to me, that's why work like this, supporting basic research, is so important and why we need it. Stay curious and get your vaccine as soon as you can. I'm really ready for this to be over. As always, a very special thank you to everyone who supports the show on Patreon. If you'd like to learn more about our community, there's a link down in the description where you can learn
Here
more.
comes the bad
We
joke.
really appreciate your support. And if you don't want to support us that way, we're just glad you're here learning with us this week. And I'll see you in the next video. Who's there?
That's Breeze knock knock. Vaccinate.
Vaccinate who?
Vaccinate everyone.
That was pretty good.
Yeah, you can't really see it. But then he says, I'll keep you. There's really, I know that it is a trigger. Social, cultural trigger. Lots of triggers in that video. But I do think that they mean well. I really, really do. Okay, so we're going to, I see the light dancing around. It's really cool. All right, let's see. Just in case you were ever wondering where that came from, now you know. There are many apps for the virtual fireplace. Okay, so we've got a little under 45, well, yeah, a little under 40 minutes to go ahead and wrap this up and see if I can, well, I know that I can. I know that I can definitely contribute to your understanding, but on these specific matters, because at the end of the day, I believe that the video is helpful to some of you. To the others of you, you generally have an understanding about the mechanism of any vaccination. And you generally have an understanding, because I've seen some of your posts, I watch, I visit many different pages and many different groups to just understand what concerns everybody. And that's very important for your future president to do on a regular basis. So I want you to know that I'm doing that actively on a regular basis. And I'm not in a political seat, so I am not under any type of solicitation or necessity to do so. I'm doing so because it matters to me. It matters to my son. It matters to my family. And it matters to people. I am people too. Okay? So, all right, here we go. I'm a note-taking lover, right? Okay, so number one, I just want to clarify. So we know that viruses do not die. So that was inaccurate information. However, it similar to when people say you need to clean a lab. There's sanitizing, which is different from cleaning. Cleaning is surface. Sanitizing is much like sterilization. And sterilization is much more like what they're proposing with the spike protein vaccination, is basically stabilizing the virus. So you're basically making the environment sterile, making it non-productive, making it non-replicating, that type of thing. But you're effectively doing the same thing when you sanitize or you disinfect. But cleaning is just surface. It is not anything other than that. So when you hear dead and you hear virus, some of you are like, oh, well, that doesn't make any sense. Or you're thinking, oh, yeah, we can kill viruses and we're done. Clearly, just look at the history of viral outbreaks and viruses in general. The common cold is a great example of this, and the flu. And this also lends toward clarifying the issue on whether or not immunity is absolute. So please understand that we scientists, we speak in these generalized terms because you've told us a million times over that you don't want to hear high-level language. And even where there are those in the population who can generally follow along with our high-level language, you equally don't want to hear it. And keep in mind that there are individuals, a significant population of us, who cannot follow along and easily or aptly comprehend the concepts, aside from necessarily terminology, but cannot understand the concepts of that which we speak. So we use terms that articulate effectively for the masses, right? So this generalization. So we say dead, but the virus doesn't die. You want it to be inactivated. You want it to be compromised. You want it because it is and there is still much debate because the definition of life in the scientific community and what new discoveries they have found about a virus lend toward validity in assigning that definition to a virus. So you may hear terms and they're not necessarily wrong. They're just understand that through the process of science, it is a evolving a discipline, if you will. And it must be because that is the nature of science. It is based on inquiry and reiterations and iterations on different methodology into different subject matter, right? As it relates to our well-being and understanding of our large ecosystem, the Earth, and our macro ecosystem, the universe, and how we play a role in that, and how we can preserve our generations and have quality of life, and just figure out all the stuff that that would be relevant to our existence and sustainability of the same. Okay, so boom, 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 boom. Now you understand why we use general terms. I'm equally going to use some general terms. You can look up definitions. I don't want to insult your intelligence, but we're going to jump right in as it relates to trying to clarify, or we're not going to try. I am going to clarify today, why are there so many vaccines? Which is best? Or are the differences even important? Then number 2, my warnings against taking the first rollout of vaccinations. And when I say vaccinations, some of you should say, well, wait, Tigress, something's not quite right with that because they've only approved one. Ding, 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 ding. So the first rollout of the FDA approved Pfizer vaccine, and then what we expect, the anticipated rollout of other vaccines that are soon to be approved by the FDA as well. And why my recommendations are as such. Okay, so here we go. All right, so why are there so many vaccines? Because, again, science is an evolving discipline. It is a discipline whereby scientists, and that's why we call it a community. You hear us refer to the scientific community all the time. We are the scientific community. When you hear political community, it's different. You normally hear arena, like it's, like this totally different aspect. Community implies that we are working together, like we all are vested in this process. There's, the political arena. We're not vying for a spot. Yes, every once in a while. And of course, seeking achievements is important to the scientific community, and scientists therein. But our greater development as a whole is and should be the goal of every scientist that signs on to the job, because it is not about you. One person in this region may, make profound discoveries on the basis of a particular ecosystem that they're studying. And then on the other side of the world, there may be a similar study, different methodology, different ecosystem. And all of these are relevant because when you put all of this data into one database, and that's what they're doing, they're compiling databases. And this is, trust me, we're getting to the segue, and this is why there are so many vaccines and why they're able to make them fast, okay? When you put all this data into our journal articles, if you will, and this data is compiled and categorized, right? And econometrically analyzed and qualitatively analyzed. Then we have this database to refer back to so that we don't have to start from the beginning. It's a very wonderful process. And that's what's going on here. You want there to be many vaccines. You don't want there to be just one company that effectively is monopolizing the production of vaccines and research on the same. We all have different DNA. We know that. We know that our genetic makeup is wildly complex and beautiful. We know that the region of our origin is relevant. The ecosystems that we are native to, they're relevant to our adaptation, our genetics, our needs scientifically as well. We know these things. These things have been proven. And so it is very important that we get scientists to contribute from their respective neck of the woods, if you will, and put all this information into this one database so that we can have basically a bigger brain together. It's officially this huge brain that the scientific community has compiled. And as we work together and continue to contribute, it's basically Transformers at its finest. And what else would you expect from scientists? It's beautiful. And it's the very core of it is just a beautiful, magical process. And I know that I'm absolutely head over heels in love with science, but I want you to see this is why. This is mainly why. And so I'm not so much as, and I'm actually very, 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 very proud of the work that has been undertaken in the last year and in recent years, in fact, and the collaborative efforts that are being made. It's such a beautiful thing that one scientist can call up another research facility, in a totally different country, and they can collaborate. This is what we need. This is important to our viability as a civilization, and really getting a handle on cancer, getting a handle on diabetes, getting a handle on HIV, just getting a handle so that we can survive this process. Now, here's a caveat, and I shared this in a video that I made on my personal Facebook page, and I didn't share it publicly. So this caveat is just a theorizing. It's not conspiracy theory. So we're gonna right there. Let's cross that out. No. I am not trying to instill fear. No. I am not trying to take focus away from the great advancements that are being made in scientific research on pathogens, which is, viruses, bacteria, diseases, overall health, and human safety. I'm not taking away from that in any way. That is not my intention. But I'm going to say these three things. And I should have had queued up my favorite quote from Jurassic Park. Life will find a way. And that is true. We are not, and this is also why it's very important to have so many vaccines, and have that to be ongoing research, and equally to have that be a planned process, hence the term pandemic. Now, some of you have said, well, oh gosh, this is a pandemic because now we see it's been exposed that Obama wrote up this big old plan on how to manage the next pandemic. Well, no, okay, we talk about, you got to have a plan. We talk about it. Come on, y'all. Let's not, remember, we got a screen door on our minds. Okay? And you can think of it like digestion. You've heard these two colloquialisms. You digest the meat, you spit out the bones. I'm going to say spit out the bones and the gristle. Don't digest the gristle. Right now, that's what's going on. I'm adding to this colloquialism. I'm going to put it on a shirt, too. So this is trademark in real time, because some of y'all love to take other people's intellectual property. But nonetheless, that gristle is now even important for us to remember. Don't eat that damn gristle. If you are having a tough time chewing it down, breaking it down with your choppers, why are you going to send that into your digestive system? Do you not like yourself? You just, what? Oh yeah, we're just going to eat a truck today. No, friends. So what's, let's cross references and think of this in common terms. What do they say? You need a plan B. We have heard that our entire lives. Need a plan B. The plandemic, as this has been colloquially popularized, and the conspiracy theory that is being suggested therein. You guys, it doesn't serve us well to think this way. Yes, will there be corruption in every plan? Nearly every plan known to man, there has been either corruption committed and carried out, carried out to their intended end, or it has been attempted or thought about in every plan. Every plan, every type of plan. You can think of drug trafficking, human trafficking, robbery, fraud, security investments fraud, murder, rape, mayhem, vehicular manslaughter, or, that wouldn't entail mens rea, but you get what I'm saying. So, okay. Or generally wouldn't be a malicious heart is what I'm getting at, a malignant heart. The point I'm making is that corruption exists, and we talked about this before, and I want to reiterate this. So you can't just focus on that element and say, okay, well, because corruption exists, then any plan is a bad plan. No, that's not accurate. So let's take that out. We're crossing that out, take that out, put that, don't even put it on the shelf. Just go and throw that out in the trash, because that's not going to serve us well. We already know that corruption exists. We need to set our focus, not forget that corruption exists, remember it. So I guess maybe don't take it to the trash. Just sit it on the shelf, put it in a safety, like a safe deposit box. Leave it there, okay? But for the sake of this, we need all the research facilities, all the research scientists that are delving into this so that they can give us more quality of life. And I know that even in sometimes I feel like, I'm watching the movies and I'm like, is this population control? Well, think about it. Is it really population control if they're trying to keep us all alive? Because I'm not trying to be funny, but the truth of the matter is, If they want a population control, you all are giving it to them voluntarily by not following the CDC guidelines. So the fact that they're trying to rush a vaccine and, you know, and making all this effort, you should see that as a positive. That's a positive generally. And this is not something that we're paying for. So yes, in time past, we're concerned about pharmaceuticals. We're concerned about pharmaceutical companies getting over on us. Yes, we're concerned about over-the-counter drugs that have been abused in homes, and now they are translating into chronic diseases that were not well defined or well researched in previous studies. So, you know, you've got all these things, you know, these negative externalities that I like to call them, that are now the burden of individuals who, unbeknownst to them, were taking prescriptions or taking over-the-counter drugs and thinking that they would be perfectly fine, and then find themselves with worser. And some of you know that that kind of humor, Jamaican humor, with the intensifying an adjective by adding on another er, as opposed to saying more beneficial or happier. That if you want more happier, then it would be happier or worser. Okay. So nonetheless, my point is, we have to use this screen door. We have to use our discernment. We have to think rationally here, okay? So that answers your question, why are there so many vaccines? And which is best, or are the differences important? Now we'll touch upon that. So right now, because there is an approval from the FDA, it can be inferred that it is the best vaccine to date. You can't say it's the best vaccine on the market because it's the only vaccine on the market, because it's the only one that has been approved by the FDA, okay? The best, when we use this term, the best vaccine is really going to be specific to your genetic makeup, your particular physical health, whether you suffer from diabetes or a respiratory, a chronic, or just severe respiratory condition, MS, any of the other neurological conditions, gastrointestinal disorders, heart disease, kidney disease, liver disease, lung disease. Any of those are going to be relevant when you want to assign the title of best to any particular vaccine. This and this kind of is a segue, but I'm going to pull it back because I want to talk about the differences. This is the segue that would lead us to my warnings against taking the first rollout of the Pfizer vaccine, or vaccines period. You know, just the first rollout, which is right now the FDA approved Pfizer vaccine. The Pfizer vaccine, as they have touched upon in the video that I shared, is a spike protein based vaccine. So you saw the video, so you understand the mechanism. What's going on here? The biggest difference between the mRNA vaccine and the spike protein vaccine is that the mRNA, the messenger RNA, it goes in like a little, our own little, our own little soldier, our nano soldier, and we send them in and we say, hey, yay, go in and take care of this by sending a message to our own innate. That means in its own natural state. No adaptation, no no drug that we've added. It is just mRNA. It's like sending in another little envelope of genetic code, because a lot of you have heard of the virus being this envelope of genetic code, right? And this genetic code you can think of as a letter, like a written letter, right? And so the virus letter says go in, destroy, kill, maim, harm, go after kidneys, liver, heart, lungs, okay, boom. Okay. The mRNA, it goes in that letter that we put, it's like a message in the bottle, right? So the message that you put in this bottle, it says, okay, go in and get their ass. Okay? And more literally so, it says go in and produce antigens that will eradicate this virus. And so what you have here is a 3-step process in both methodology, but what is skipped with the spike protein methodology is the activation of your own innate immune reaction, if you will. So with the, let's see here, with the mRNA, and some of you are familiar with this, lipids and fats and or fatty nanoparticles and nuclear waste and wetlands. Some of you are familiar with this. Lipids or fat in biochemistry or chemistry has a very high surface area, and very similar to clay. That's soil. It has a high surface area, the highest, in fact, when you're talking about soil profiles. And so that can be a very bad thing and a very good thing as well. Because basically in this lipid tissue or in the lipids and these nanoparticles, fatty nanoparticles, you can have these biochemical processes that we can use as a benefit for the purpose of vaccination, right? Okay. And in wetland bioremediation, these are environments that can be bad because they do not lend towards stabilizing nuclear waste. And some of you know that as far as like refuse cells and having to convert refuse cells that were clay lined to another form of nuclear waste mitigation and remediation services. So nonetheless, the point I'm making is that I think most of us have a negative association with fat anyway. So you can think of it in that regard as far as serving an app site to deliver this mRNA directly to the cell, and it skips the activation of your innate immunity because it is the message. It is the message in the bottle. And basically, instead, what occurs is you have the next step is like when the antibodies, you have induced antibodies, which is good, right? And then you have a cell-mediated immunity or adaptive immunity. And that just means that basically your cell, when you think mediated, just like remediation, you're making something better, you remedy it, right? So think of it as now having these receptors for the spikes on the coronavirus that would then stabilize, right? So that the ultimate goal, stabilize, which is immunity. You can think of those terms as being very similar in this scope of science. And then you don't have the coronavirus. So do you literally have it in your body? Yes, I told you. They make up, they're very, very small, infinitely small, infinitesimally small. So they're everywhere, just like we have microorganisms that are everywhere and bacteria everywhere. But the goal is to keep them dormant and inactivated, right? Okay, so and that kind of touches upon the adenovirus vector vaccines as well, which is like Janssen, and I mentioned that while that video was running. So, all right, which are best? We go right back to that. It really is going to depend on your current physical health and any pre-existing conditions. Are the differences important? Yes, they would be highly important as it relates to that. If you have a history of respiratory disease, or if you have a history of lung disease, the oh goodness, hold on one second, because I wanted to touch upon this in my little note. The adenovirus would not be the best for you to take, because the adenovirus is, most of you can associate the adenovirus with like the common cold, right? So you're basically being introduced to that. That's being introduced to your body. So you can have a very heightened, severe inflammatory response or allergic reaction to that, and just eventually just have the respiratory condition, and it can be worse, or it can be significantly worsened. So yes, we don't really want to see more adenovirus, especially adenovirus that our body already has an immunity to, because it is not going to be effective in tackling this particular vaccine. We want to see the adenovirus vaccines use more rare AD vectors, if you will. And I believe there are studies in China right now for an AD25, if you will. And that would be a lot more effective. The efficacy would be greater because it would be rare. And so there wouldn't already be this pre-existing immunity, which would basically render the vaccine completely pointless, if you will, and ineffective. Okay, so we're getting there. All right, hold on one second, because I wanted to make sure. Okay, so, and the difference between the adenovirus vector and the mRNA, and there are two different versions of that as well. There's there's another option to the MF59 with the RBD. And those vaccines have also shown to not be as effective as the mRNA. So if you see something with MF59 plus RBD, and it's a binding, RBD is, I can't think of hold on, it's a receptor binding domain. So if you see that, then research those particular vaccines. If in your particular area, this is what's being rolled out first, because I don't know what's going on from country to country. I barely can keep what's going on in this country with all the chaos, especially right now, and in recent years. So look it up in Google Scholar. And I'm so proud. I hope that I had made a contribution in this particular regard, because today when I went to look up whether or not there had been 120-day post immunization findings, because I see a lot of 60-day post immunization findings that have been reported, but I wanted to see some more long term, especially considering the fact that we've been in this pandemic for about 8 months. So there can be some 6-month findings that we need to see, and I want to see them. I see a lot of things that haven't been documented, as far as like allergic reactions in Wuhan, China, studies that went terribly wrong, but nothing's been documented. They only reported the information in their summary from the information that patients shared with them. You know what I mean? But other than that, it was not actually documented in a controlled environment type of thing. Okay, so when I went to look up whether or not, I just typed in the keywords 120-day immunization, I was so pleased to see that it was amongst the top searches. You know how when you start typing and things start to pop up, and there is an implication, because I hadn't looked up any of that on my computer, so it would not have been within kind of like the cookies of my previous searches. I was very delightfully pleased to see that you all are looking it up. Yay. Yay. They're available to you. This is how we communicate to the general public when we scientists are otherwise. And it's not so much as that it's driven only by the fact that we are introverts, but we use that medium that, so you have politics generally uses the traditional news media like CNN, right? And they communicate with us through that, right? Or they communicate with us through statutory revisions that a lot of you don't look up, and I want you to do that too. You can just go to any of your state general statutes, you can search that, and they have to be readily available to you because they are holding you to the law. They want you to comply with the law. So inherent in the law is that they must publicize the law. It must be made available to you so that you have knowledge of it, because they say ignorance is not a defense, right? Boom, friends. Okay, so here we go. Again, I am just so excited to see that you're looking it up. Look it all up. You are privy to it. You are contractually privy to it. The federal government is a fiduciary. They owe us that very basal right and opportunity to have full access to the law, full access to the courts, full access to research, full access. And this, the journals are that medium whereby scientists communicate to you. And I've been saying that so often, but I wanted to really just state it finitely. And I've been saying it a lot amongst my science colleagues to let them know that a lot of people are not reading the journal articles, and we take great pride in having a published article and, profound findings and contributing to our, scientific big brain. We love this. We love it. And a lot of scientists are thinking that you're reading it. You may not understand all the high level information. That's why they're abstracts. The abstracts are not for us scientists. Come on, friends. They're not for us scientists. They're because we want you to understand what we're talking about. There needs to be an understanding and cross application for interdisciplinary research and application in this advancement of our society, our entire civilization, both national and global. Boom. Okay, so, all right. Here we go. All right. So here's the other difference. The difference between the spike protein and the adenovirus, because now we know the adenovirus is basically, kind of, I don't want to call it antiquated, but the most popular adenoviruses, like a AD5, those are like the common cold or whatever. Those are overdone, kind of antiquated. That's really not going to work. We need advancements. Now, they may find some more advancements, so I don't want to shut that down completely, because there may be methodology that can revive the efficacy of using an AD vector or AD5 vector vaccine. Don't know. I can't say that 100%. As a good scientist, none of us would say that, because we're ever learning, because we don't, at the end of the day, and you should have an expectation, we don't know everything. But amongst the people on this earth who are delving in and in making legitimate inquiry into the functionality of things and understanding everything around us, the world around us, we do qualify as, apt. So you should generally trust us, okay? Generally. Remember, I say this all the time, always with that caveat. Make sure it's a trusted professional. Make sure you're going to resources that are trusted and vetted. That means that they have been peer reviewed. And the peer review, yes, there can be corruption in peer review, but generally, because there's corruption in every aspect, so that we can leave in that safety deposit box, like I said, on the shelf, because that is something that's going to exist forever. It is unfortunate, but I don't think that we can completely eradicate corruption, but we can get better at pinpointing and limiting and preventing and quickly remediating that type of corruption. So in the greater concept of everything, we can trust those the systems that we have in place. Now, I know we have some issues with our legal system. We're working on that, and our political system. But generally, the scientific community is here because this is what we want. We want better. We thrive on better. You can trust us more with getting closer and closer to better because it makes us look good, quote unquote. You don't want to be a scientist and be known as the scientist who made things worse. Not that. No, you want to be the scientist like, yes, I created nanobots, and there you have it. Right. So that's why it makes it a lot more trustworthy discipline. Okay. And now you have the differences as it relates to, and I have to stop here in about 10 minutes because time is up. But as it relates specifically to the spike protein, you're not really, what's going on is they're not really sending a message in. It's not the virus. The virus itself is not being reintroduced to your body. Instead, as you saw in the video, it's a portion of, it's almost like with horticulture, and you want to transplant, right? So it's a transplant of sorts, right? In hopes that it will catalyze a reaction in your body to produce an immunity to this foreign agent, and then thereby an immunity to the coronavirus as a whole. Boom, okay? So these are awesome, good things. Awesome good things. However, and as I've already stated, now this particular virus, the biggest issue is that from the tests and the studies that I've seen, is that their patients, the participants in the study, have not had any immunocompromised issues, basically not part of the vulnerable community. So I completely concur with the scientific community, those of us in this community that are concerned about the vulnerable community. And remember, I have ascertained and I have asserted, and I will reassert right now, that we all are a part of the vulnerable community, all of us. However, there is validity in the designation of a specific vulnerable community, one that is more susceptible to severe reactions, inflammatory responses to these vaccines due to pre-existing conditions. Now, you would think that this would be commonsensical. You would think, okay? So the good thing is, if you do proceed with taking the Pfizer vaccine, you can at least be somewhat reassured that it's not the vaccine itself. My biggest concern is that there have not been enough studies. It has not been enlarged enough to substantiate an FDA approval. Now, it may literally meet the criteria for FDA approval, but as we have seen, that FDA approval of other drugs has not prohibited or did not mean that those drugs would not have long-term impacts or long-term effects, and detrimentally so, okay? So I understand the need. So I'm being reasonable here. I understand where we have this emergent need for a fix. Okay. We have a wonderful methodology, replacement methodology, excuse me, because it's going to replace or temporarily right now, because we don't want to use the adenovirus or the AD5 vector vaccine. We and the AD25 vector vaccine is still under study, so it's not ready for approval to date, to the best of my knowledge. Or I'm sorry, I keep saying AD25, it's AD26. Okay. But it appears that AstraZeneca and Janssen are doing studies in that regard. They're still working on the same methodology. And I don't mean to say same, like to say it in a derogatory fashion, but they are enlarging their study of vaccinations using adenoviruses, just not the adenovirus 5, which is proven to be less likely efficacious for our needs with this new coronavirus. And the Pfizer, so Moderna also, as you saw, Moderna and what was it, BioNTech, and Johnson & Johnson, they all are working on this spike protein vaccine. It's very, very interesting, but it does skip the step of having to actually send in a message. So it's not necessarily mRNA. It's nanotechnology at its finest, in my opinion, because they have and actually, I guess these elements would be considered larger than maybe some nanoparticles. But basically, they are farming cells, so clone, if you will, and in the cells, they are using this cell farm to see if it would replicate or produce more of the spike proteins if introduced to the cell. And they found that it did. It did induce production of those spike proteins. And then you have the cell-mediated immunity, because the cell now is going to effectively take on the same structure. And it has transformed like a transformer would. And it has, the spikes that can, for the receptors that will stabilize it and prevent it from migrating into the cell, invading, and then infecting the host, which is you or me, right? So it's a very interesting concept, y'all. Very, very interesting concept. I would say, if I had to take a gander, that it seems like it would be more safe than what we more traditionally see as a more naturally kind of adaptation process that is similar with the mRNA and the adenovirus methodology. My biggest concerns are what I will repeat: the fact that there are no 120 day post immunization findings that have been reported, and that substantiate a true approval, as opposed to just like FDA criteria approval, like an absolute approval of the Pfizer vaccine. The already specifically designated vulnerable community, and it actually has also shown to be particularly concerning. Well, that would be the AD5 vector vaccine for children. That the inflammatory response is even stronger than the viral infection, if you will, in that vaccine. So I'm just concerned. I'm concerned because, remember, my child is part of the vulnerable community. I can be considered part of the vulnerable community as well, because I have a long-term or chronic upper respiratory condition. But a lot of this is related to a increase in eosinophils in our bodies on the basis of having taken acetaminophen during my pregnancy for pain to manage, fibroids, which made my pregnancy a very, very high risk. So it wasn't the codeine because I took hydrocodone or Vicodin. So it wasn't the narcotic, and instead it was the Tylenol that even though it was taken consistent with the dosaging, it still translated negatively into both my system and that of my son. So, and that's another one of my concerns because I was the one, and I probably won't get any credit for this, but I was the one that discovered it. I thankfully have great allergists and gastroenterologists who were excited to work with me as a scientist and to lend my support in doing the kind of research behind the scenes as it related and keeping up a log with our symptoms so that we could I could help them identify the cause of our ailment. And the increase in eosinophils was exactly it, because some of you already know that my son has already been diagnosed with eosinophilic esophagitis. And this is an emerging discovery. More children and adults have been diagnosed with this. And this is my concern with the drugs that we have, because the prevalence, the spike in cases of eosinophilic esophagitis or increased eosinophils, which basically looks it's like a less severe case of maybe lupus, almost the body attacking itself, because we basically just we've taped a problem, if you will. And so the problem is still there, and basically it eventually busts out of the tape. The tape will become, less durable over time, and basically the tape won't work anymore. And that's effectively what's going on. Or you have a cap, like a manhole, right? But when you know that the pressure of the water is so great after it's built up, and then it explodes, and the cap, that it will not, it will no longer work. It no longer has the efficacy. And so that's what's going on. So this is where my concern lies with all of our vaccines and all of our scientific study. And that's exactly why there are so many vaccines, because there will continue to be research on the same, and there will continue to be, we want that to be the case, that there will be advances. However, in the interim, you say, well, which is better? Because we have so many people who are not following the guidelines. The best case scenario is if we were to follow the guidelines, but we can't sit in the house forever. That's not going to be realistic either. Not on this beautiful earth. I don't want to have to do that, just sit in the house all the time. No one wants to do that. We have to find ways to live viably on this earth. Now, I have my theories as to why the earth is quote unquote reacting in this way. But I won't go into detail about that on this particular feed. So I believe that I've answered all the questions. Let me make sure. Why so many vaccines? Check. Which is best? Check. Or are differences important? Check. My warnings against taking the first rollout of Pfizer vaccine or any soon to be approved vaccine? Check. And why? All right. So I really hope that you have your understanding of it all has been enlarged with this live session of Evolve Weekly. I am Tigress Sydney Acute McDaniel, your host, your delighted host, and I hope that you have a wonderful, wonderful day and an awesome week ahead. We can do this. And wear your mask, people.